All right, everybody, welcome back for another deep dive. And today we're diving into a topic I'm sure you've heard whispers about, maybe even some outright scary headlines. Quantum computers.
Mm.
Specifically, what they could mean for all that data we're all constantly flinging around online. I mean, quantum computers could shatter encryption.
Yeah.
That's enough to make anyone
Yeah.
hit that panic button, right?
Oh, yeah.
But before we all run for the digital hills, we're going to break it down today. Figure out how much worry is really warranted. We've got this article here, really gets into the nitty-gritty. And let me tell you, some of this stuff had my head spinning.
It's mind-bending for sure. Quantum computing is not your grandpa's computer, that's for sure.
Not at all.
Yeah.
So let's start basic then. This RSA encryption, the article keeps mentioning it. Is that something the average Joe, should actually care about?
Use it every day, multiple times, guaranteed. You just don't know it. Secure websites, messaging apps, if you bank online, bam, that's all writing on RSA encryption to keep things safe.
Okay, so this RSA is kind of a big deal then. How's it actually work, though?
At the core, it's like a ridiculously hard math problem. Think a number so huge, regular computers, the ones we're used to, would take millions of years to crack it. That's basically the wall protecting your data.
And that's where quantum computers come in to ruin the party.
See, about quantum computers, they're not just faster, like souped-up versions of what we got. It's fundamentally different how they handle information. Think of it like this regular computer, light switch. On or off, 1 or 0, right?
Makes sense.
Quantum computer, it's like a dimmer. It can be on, off, or anywhere in between, all at the same dang time.
Hold on, it can be a 1, a 0, A and D both? How does that even...
Superposition, it's called. Part of what makes them so powerful. Explore tons of possibilities at once, so some problems like breaking encryption, they can do way faster than our classical computers ever could.
So are we doomed, is what you're saying? Time to start writing passwords on sticky notes again?
Not quite. Big difference between cracking some basic code and the encryption keeping your data safe. Article mentioned this quantum computer. It factored a number, which is cool and all, but that number, it was tiny compared to what's used in the real deal.
So maybe not a time to panic just yet.
Yeah.
But it sounds like it's just a matter of time before they're strong enough to bust through those defenses we got. Is that really it? Are we all headed for a digital meltdown?
That's the million-dollar question. Truth is, we don't know for sure. Not yet, at least.
So we just wait around then, twiddle our thumbs and hope these quantum computers don't turn into some supervillain's dream machine.
Not quite. The article actually, it highlighted a few big hurdles, things quantum computers got to overcome. It's not like just build a bigger one and it's game over.
Oh, really?
Yeah.
What's standing in their way then? What's keeping our data safe for now?
Well, one of the big ones, it's called error correction. See, quantum computers, they're sensitive, like really sensitive. Tiniest thing throws them off. Imagine doing, I don't know, complex math, but you're on a roller coaster, blindfolded.
Yeah, that sounds like recipe for disaster more than anything.
Exactly. Huge amount of their power. It's not even for solving the problem. It's for keeping the whole thing from going haywire. Like, you got to double check every single calculation just in case a breeze messed it all up.
So it's not just building a stronger one. It's got to be reliable too. I'm starting to get why this is so hard.
And then there's making them bigger, scaling them up. The more complex it gets, those errors even harder to manage. Like herding cats, more you got, the more chaos.
Can't even imagine. So, okay, we got these powerful but finicky machines. Hard to build, even harder to keep them in line. Sounds like we're safe for now, but what about down the road? Eventually.
That's where it gets interesting. Quantum computers, they might not be cracking today's encryption tomorrow, right? But researchers, they're not just sitting on their hands either. They're working on what comes NetXT for cybersecurity, the next generation.
You mean that post-quantum cryptography that the article kind of glossed over? Sounds like something out of spy movies.
Kind of is. Basically, it's whole new types of encryption, but built from the ground up to be resistant, even to the strongest quantum computers we can dream up, theoretically.
So like a digital fortress. Walls so strong. Even if they get a battering ram, it ain't budging.
You got it. And get this, some of this stuff, it's already out there being used.
Hold up, really? I thought this was all preparing for the future, way down the line. You're telling me my stuff might already be using this quantum-resistant tech.
Yep. Article mentioned Kyber, that's one. It's already sneaking into things like Signal, that messaging app. Even Apple's iMessage, they're using it.
No way.
Yeah.
So I could be texting my buddies, all casual, but under the hood, it's got this futuristic quantum shield. That's wild.
Goes to show, yeah, quantum computers, they're a challenge, but we're not just sitting ducks. Lots of work being done, staying ahead of the game.
It's kind of comforting, knowing these brilliant folks are already all over this, like a cyber SWAT team or something. But it also makes you think, right, if we got quantum-proof texting already, what else is cooking? What's next?
See, that's the fun part. We've been talking encryption, yeah. But quantum computing, that rabbit hole goes way deeper. Whole other fields, this could turn them upside down.
Oh, okay. Now you have my attention. What kind of upside down are we talking here?
Imagine, like, medicine, but we're designing drugs, perfect accuracy every time. Or materials, stuff we haven't even dreamed up yet because of how this works.
Yeah.
AI even, but the kind that learns like our brains do, not just crunching numbers.
Well, hold up. So this is like Renaissance level stuff, but for computers.
That's the potential, yeah, for sure.
Crazy. But okay, gotta ask, with all this amazing future talk,
Mm-hmm.
what about right now? What's still gotta happen?
You're right. Not all sunshine and roses. We talked errors, making them bigger, but
Yeah.
also who gets to use these things? Right now, they're pricey, complicated. Most folks can't even touch them.
Like having a spaceship, but only like 5 people know how to fly it.
Exactly. Making quantum accessible. That's huge. Not
Yeah.
just for science, but so everyone benefits,
Right, right. Because even the best tech is only as good as the folks using it in the end.
100%. That's why we talk about it, right? More we understand, the better ready we are for good or bad when it comes.
Well said. So we're wrapping up here, and seems like quantum computing, it's a lot. Powerful, changing fast, could rewrite the rules the whole 9 yards.
Yeah, and it's not if, but way-o when. For a lot of this stuff, it's coming.
And hey, that encryption worry, it's real, but we're not defenseless. Smart people are on the case, that's for sure.
For sure. It's like a dance,
Yeah.
Tech steps one way, we got to step the other. Keep up.
Because this deep dive, man, more questions than answers now, but that's a good thing, I think. Speaking of, one last one for you all listening. What would you want to see quantum change? For you. Let us know. And in the show notes, got some links if you want to dive deeper yourself. Until next time, keep those brains buzzing.